Once again I welcome back COA online class. So this is continuation for previous one. In the previous class I will explain only register transfer language. In the register transfer language, what is register, how the register is represented in COA, that is computer organization, that is in the register is represented in capital letter R. It denotes as a register. Then next, how the register is transfer information from one register to another, or register to memory, then memory to registers. So these are all the things already I discussed in the previous video. Now this is another topic, bus and memory transfer. Here what is bus and memory transfer? Bus is a path, that is a group of wires, also called as group of wires. So what is the use of bus? The bus, it can carries signals means it carries information, that is information is transferred from source to destination. That is a simple meaning. So bus, it carries information one place to another place, that is source to destination. That is the definition. Here one symbolic representation is registered to bus. Here R is register, it from bus. Okay, the meaning is for a bus transfer may mention the bus or its presence may be implied in the statement. So what is the register? The content of the register is transferred to bus, that is the meaning. Or the content of bus, the content of the bus is loaded to register. So there are two meanings, one is register to bus, another one is bus to register. Okay, these are all the some symbolic representation, that means the information will be transferred, registered to bus or bus to register. Here you see that the content of register C is placed on the bus, that is first one, and likewise the content of the bus is loaded into the register, that is for bus to R1, that is register 1. Okay, so this is known as bus for carrying information from source to destination by using registers. Okay, go to next. In the common bus system, it reduces number of wires, because suppose if you want to transfer some amount of data by using several number of buses, that is the circuit size is very large. But by using common bus system, using multiplexers to construct a common bus, it reduces number of wires, that is reduce number of buses, by transferring information from register to bus or bus to register. That is the only way for using multiplexers. The multiplexer is a technique that accept many input but give only one output. You already know that multiplexers in digital, multiplexer is a circuit which accept many input but give only one output, that is many to one. The only example, the real time example is in telecommunication, several telephone calls are carried through single wire, that is the logic of multiplexers, because it reduces number of buses, only a one bus, only one wire, it transfer or it carry or it accept many inputs, that is many uh, input lines. Okay, so this is known as multiplexer. Here in common bus system, by using a multiplexers, it construct common it construct a one circuit for transferring information, that is registered to bus. Here there are four registers: register A, register B, register C, and register D. But the only one bus line is there for interconnecting all the buses. Okay, it communicate all the other word is it communicate all the registers. Only one bus it communicate all the registers. Okay, so this is for common bus system. Okay, next, in the common bus system, by using multiplexers, that means it select four registers. How it select? There are two selection lines are there. Suppose if you take 4 into 1 multiplexer, it takes only two selection lines. Or you get 8 into 1 multiplexer, you will get three selection inputs. 16 into 1 multiplexer, you get four selection lines. Likewise, you can change the number of multiplexer, the selection lines also incremented. In the common bus system, the four register, that is 4 bits each register we need, that is 4 into 1, 4 input we get 1 output. Okay, that is multiple input and one output, that is known as multiplexer. But you will need two selection lines. The selection line becomes S0 and S1. Suppose the selection line is 0 0 active low, it will select register A. Or the only one selection line becomes I, that is S0 is I, B register will be selected. Likewise, S1 is active, S0 is low, it will select register C. Likewise, both the selection lines becomes I, the D register is selected. Okay, so this is the logic of selecting outputs. Okay, go through the internal architecture of common bus system. Okay, so here there are four multiplexers, that is 4 into 1 all the four multiplexer is known as 4 into 1 multiplexer, that is 4 into 1 here, 4 into 1, this is also 4 into 1. All the four multiplexer are 4 into 1, so it will take four inputs and one output. Okay, so four inputs is nothing but uh, before that it connects all the register, that is register A, register B, register C, and register D. All are 4-bit registers. Okay, the 4-bit register, it will take only 4 bits. Okay, so that is A0, A1, A2, A3. Likewise, B0, B1, B2, C0, C1, C2, then D0, D1, D2, D3. Okay, all the four registers will take 4 bits. But in multiplexer, first time it will take all the 4 register becomes 0, that is A0, B0, C0, D0. Second, the second multiplexer, that is multiplexer 1, will take A1, B1, C1, D1, A2, B2, C2, D2 for multiplexer 2. Okay, so these are all the some uh, buses or informations connected to common bus. But in register A, it will take the A3 to the bus in the multiplexer 3. Likewise, B3 is connected to multiplexer 3, C3 is connected, D3 is connected. Uh, S0 and S1, these two are status signal, that is selection line. The selection lines are connected all the four multiplexers. Here S0 and S1 is connected. Here also S0 and S1 is connected. Here then the last, that is a first multiplex, that is multiplexer 0 also connected. S0 and S1. Okay, where commonly the selection lines are connected all the 4 into 1 multiplexer. The output is for the 4 multiplexer, it will give only one output. Here will give one output. The green lines are the output. Okay, a 4 line common bus. It is 4 line common bus. All the 4 multiplexer will give one output. All the 4 output will give the common bus, that is known as a common bus system. Okay, so what is bus and what is common bus? What is common bus system? Bus is uh, the way of that is the carry signals from one place to another place, that is source to destination. Then how to construct common bus system? It reduce number of wires, that's why I'm using multiplexers. Multiplexer is multiple input, and multiple inputs are carrying only a single line, that is a single wire. That's why I'm taking multiplexer. So 4 into 1 multiplexer I am taking. So in the 4 into 1 multiplexer, it will take 4 input and 1 output. So all the 1 output for 4 multiplexer, for it, the carry information from common bus. Likewise, we can add more number of multiplexer also. The outputs are same, carry a common bus. Okay, so this is known as bus and common bus system. Okay, thank you. We will see in the next class for the next topic in the register transfer language. Okay, thank you. Keep on watching. If you need out, contact me.